Hello, hello. It's such a pleasure to have you back on my channel. Thank you for staying with me. Today, we'll be going into conversion of fractions to decimal. So, we'll be converting fraction to decimal. Now, certain things happen when you convert fractions to decimal. First, there are two things that can actually happen when you convert to decimal. So, here are the two things. It's if you have a fraction, you have A upon B, you have to divide, you have A divided by B. So if you are dividing this, is either you have a terminal fraction or a terminal decimal rather, or you have a reoccurring decimal. So it's either you have, let me say, AB dot B C straight up, or you have C upon D to be equals to you have A comma B. Okay, you have B, AB, then dot you have C, you're having D, then it keeps D, and you're having another D. Okay, let me do this to help you out. You are having you have another D, another D, another D. What are you seeing? From after the C, you have D, another D. It keeps reoccurring. So these are the two cases you can likely have. So let me just walk you through these examples I have on the board so that you will see the cases for yourself. So if you are having the first example, let's solve. Have this solution. Don't mind my solution. So you have solution 1 upon 2. This is what type of fraction? It's a proper fraction because our denominator is way bigger than the numerator. But it will still result into a decimal if you divide. Yes, except you have a numerator that the denominator can divide, that is, the denominator is a factor of. If the denominator is not a factor of the numerator, it will result into decimal fraction, irrespective of the fact that it's either a proper fraction or an improper fraction. So let's go here. 2 in 1. And check how many 2 do you have in 1? Of course, 2 cannot go in 1. You have 1. This is 1. And you want to check how many times. This is 2. How many 2 can you see? How many of these 2 can you see in this 1? It's not possible. You can't bring 2 out of 1. So what do? You have 0 points. That's the rule. You have 0, of course. It's not possible. That is 0. Then you have to do something to this 1, the numerator. So you put decimal here. As soon as you put decimal here, you add 0 to this place. Do you get that? Okay, let me come again. You have this. Coming again. You are having 1 at the numerator, and you have to divide by 2. 1, 2. This is 2. Count 2. So you want to pick how many 2. This sign here, this very sign, this means division sign. So you want to know how many 2 you will see in 1, isn't it? But you cannot bring out 2 from 1. You can't divide this 1 by this 2. You can't bring 2 out of 1. It's not possible. So what do you add? You add 0. When it's not possible, you have 0. Then as soon as you put your 0, what do? How do you forge ahead? There's 1 here, right? So what do? You add decimal to this place. As soon as you add your decimal, you add 0 to this numerator that you cannot divide. You add 0 to it. So once you add 0 to it, now you can say you have 10. So you can now easily check how many 2 can you see in 10. I don't have to be counting 1, 2, 3, 10. You should know that with the aid of your multiplication table, you can sort this out. 2 times what will give you 10. That's another way. or you just count your 10 if you can count. So you have 2 in 10, of course, 2 in 10, 2 into 1, 2 in 10, you have 5. No remainder. Perfect. So since there's no remainder, we are as good as done. We are as good as done. So if you have this, that means you have changed 1 upon 2, which is a fraction because it has numerator and denominator, to a decimal. What does this decimal represent? The half is 0.5. This is 0 is a whole. I've explained that before. So why this 0.5 is a fraction, and the fraction is in 1 decimal place. We still use this decimal place when we are converting from decimal back to fraction. So you have this settled. Let's check the question 2. Question 2, you have 3 upon 2. You check. I told you initially, the only thing that will not make you have a decimal number is when the denominator, which is the divisor, is a factor of the numerator. Once it's not a factor of the numerator, you will have decimal, regardless of the type of fraction it is. Look at this one. The one we did initially, 1 upon 2, was a proper fraction. Now we have an improper fraction, and we are still going to have decimal numbers. So what happens? 2 in 3, you have 1, 2, 3, you have 1, 2. How many of these can you see in this? How many of these will you see in this? This 1, 2, you count 1, 2, you have 1, 2. This is 1. 1 is left. This 1 is left. Do you see that? So since there's 1 left, this 1 is left. I've counted, so 2 in 3 is 1. There's a 2 here is 1. There's a remainder 1. I'm writing my remainder beside the number I'm dividing. So you now check again. That's the rule. The rule is you divide again until you can't divide again. You divide again until you terminate. So you have 2 in 1. Can 2 go in this 1? It's not possible. So you have decimal here. So once you have decimal here, you add what I told you, you always add 0. So you have 2 in 10, that is 5. 2 in 2 is 1, 2 in 10 is 5. So that settles the question. We are done with that. Let's go back to question 3. I believe you are getting this. It's just a simple approach. Let's check this again. Let's do this again so that you understand better. You have 2 upon 3 now. So I'll swap them. So what do you have? 3 in 2. 3 cannot divide 2. So you have 0 points. You add 0 here. So 3 in 20. 3 in 20 is 3 times 4, 12, 3 times 5, 15, 3 times 6, 18. 3 times 7, 21. It's already beyond 20. So you go back to 6. 8. 3 times 6 rather, 18. So you have 6. Means 3 will go in 26 times. What is left? 2 is left. 2 is left. You check again. 3 in 2, so that you are back to square 1. 3 in 2, it's not possible. But you have a decimal here already. You cannot add decimal again. So you add 0 again. You add 0. You have 3 in 20 again. You have 6. You still have 2 left. 2 is left again. You keep doing that. You have add 0 again. You add 0. That is 3 again in 20. That is 6. So this is what I call reoccurring decimal. The decimal number keeps reoccurring. So it will not terminate except you terminate it yourself. So what do? You can terminate at this point. Since you keep having a remainder of 2, and the more you add 0, you still keep having the remainder of 2. You keep dividing, you keep having 2. So you just terminate it here. You can just say your answer is 0.67. approximately. So approximately you have this. And that is to what decimal place? 1, 2. That is 2 decimal place. Thank you. Let's solve the last one. Solve the last one together. So you have, I want to believe you are following. Are you getting it? So in case you have any comment or any reservation, any question, any area that is shady, make sure you make use of the comment section. So you have 5 upon 7. And that becomes what? 7 in 5. 5 is smaller than 7. So 7 cannot divide 5. You have a 0 point. You add 0 here. So 7 in 50. 7 times 7 is 49. So that will be 7. 1 is left. You check 7 in 1. Is it possible? It's not possible. You add 0 to it. 7 in 10. That's 1. Remainder what? Remainder 3. You add 0 to this. 7 in 30. That's 4. Remainder what? Remainder 2. 7 times 4 is 28. So 2 is left. You keep up again. You add 0 to this. And you add 0 to it. 7 in 20. That is 2. And that is 14, right? So what is left? 6 is left. 7 in 60. 7 times 8 is 56. So you have 8. You have 8. So once you have 8, 56, 4 is left. You add 0 again. That will be 5, 35. You're still going to be having what? 5 out of. So you are coming back to this point. So at this one is not a recurring decimal, but the decimals is not recurring, but it does not still terminate. What do? Once you get to 4 decimal place and it has not terminated, you can terminate it. So you can say your answer is 0.714. If you approximate to 1, 2, 3, 3 deep, 1, 2, 3, 4, 4 decimal places, you have 3 here. So that is your answer. Thank you so much for joining me on this episode of fraction. You want to reach me, you have 081 64 86 94 and 70 70. Thank you. Thank you. I hope you get that. Okay, quickly, let me give you something to play with. Yes, I need to give you a DIY. DIY. Anyway, DIY means do it yourself. So quickly change these fractions, change it to decimal, change them to decimal. Change these fractions to decimal, 10 upon 12. So that is as good as that. We see again and again. Be safe.